Hi guys, this is Ahed with Logos Learning, and in this video we're just going to do some practice questions. We're going to derive. Let's have some fun. I'm going to use the Leibniz notation just to let you know. So let's derive y is equal to x squared minus 16. So the derivative of y with respect to x, so dy dx is equal to 2x and minus 0, so we're not going to write the minus 0. Let's do this one. dy dx, or the derivative of y with respect to x is equal to, and here we're going to have to use a chain rule. Here we have u. We're going to replace x squared minus 16 as u, and we're going to derive relative to u, so let's write it down. dy du times du dx. Now let's derive the function relative to our u. So this is 4u to the power of 3 times du dx, so the derivative of u with respect to x, which is 2x. Now I'll do one more step here. I'm going to multiply the 4 and the 2x together, so that becomes 8x times x squared minus 16 to the power of 3. Third function. So we can derive this as a quotient using the quotient rule, or we can beautify the function first. So let's change the function form and derive it using the chain rule, which is much easier and less error prone. So 2x cubed plus x to the power of minus 1. Don't forget that this whole thing here is the power of 1. So when you invert the fraction, so everything is over 1, I'm not going to write it down. When you invert the fraction, you change the sign of the exponent. So here, let's derive it. dy dx. Let's derive it relative to our u, which is what's inside the brackets. So minus 1, whatever's inside the bracket, to the power of minus 2, everything, whatever exponent here, loses the power, times the derivative of the interior, which is 6x squared plus 1. So if you don't know how I did that, please watch my earlier videos about how to derive. I give a lot of examples, so you'll be able to learn how to derive it better. Now notice here that all of these things, the minus 1, this bracket, and this bracket are all multiplied, so this is all one term. So I can move things from the denominator to the numerator very easily without having to do any difficult operations. I will leave the minus 1 here, and I'll leave the 6x squared plus 1, and I'm going to bring whatever has a negative exponent to the denominator in order to change the sign of the exponent. Do not leave any negative exponents as part of your answer. That is very ugly. And math is all about beauty. Math is very beautiful. So this is our answer. This is dy dx. This is the derivative of y with respect to x. Now, here we have a product. We have this, and we have that, and they're multiplied because there's no plus or minus in between the brackets. So what is the product rule? Let's do this. So suppose that h of x is equal to f of x times g of x. H prime of x, I'm going to write h prime, I'm not going to write x for all of them. It's going to be f prime times g plus f times g prime. So in the first term we derive one function, in the second term we derive the second function. So in here, this is our f, this is the first thing, and this is the second thing, okay? Now, let's derive dy dx. Let's derive f. Now you notice here f is a function within a function. So you have something squared and that something is a function. So we're going to have to use a chain rule. Let's derive, I'm going to use the big brackets here. So 2 something, which is our u, to the power of 1, which I will not write, times the derivative of the inside, the interior, which is 4x. Okay, so this is just f prime. This is me deriving this only. F prime times g of x. So we're going to write the second function the way it is. Do not derive the second function in the first term. So we derive only the first one first. So 4x to the power 6 plus 24x, this is very ugly, I know, minus 16. Very prone to errors. So this is the first term, f prime, and this is just g. Plus, let's write f the way it is. So 2, I'm going to write it within a small bracket, 2x squared minus 6 squared. So this is only our f, okay? Times g prime. So let's derive the second function. So we have something to the power of 5. So it'll become 5, that's something. 5 times that something, 4x to the power of 6 plus 24x minus 16. And all of that is the power of 4, right? And then we'll multiply that by the derivative of that something. And I will not be simplifying, just to let you know. So let's derive what's inside. 4 times 6 is 24, x to the power of 5 plus 24. Okay? So it's very, very common to take a product like this and to just derive f and derive g. So some people, what they like to do, so if they have h is equal to f times g, they would take h prime becomes just f prime times g prime, okay, which is incorrect. Okay, this is incorrect. You have to always recognize what kind of function you have and then derive it according to the rule. What I would like to do normally is to write all the rules on a cue card, and whenever I'm using any kind of, whenever I'm deriving, I'll just look at the rule, refer to it. No matter how smart you are, it's very easy to make mistakes in math, especially with a new concept or a newer concept. Let's move on. Now, here we have a quotient, and we're going to derive it. We can derive it with a chain rule, or we can derive it as a quotient. Let's derive it as a quotient. So let's write the quotient rule. If h is equal to, or h of x is equal to f of x over g of x, but I'm not going to write that down. Okay, h prime is equal to f prime g minus g prime f over g squared. Okay, so as we did before, we're going to derive dy dx. We're going to take, this is our f and this is our g. Okay, now let's derive f. Now, big bracket. You have 2, whatever's inside the bracket, and then to the power of 1 times the derivative was inside, which is 2x. So this is just f prime, okay? F prime. Let's write down g the way it is. G is 4x cubed minus x to the power of 4. F prime g minus g prime. Let's derive g. Now 4 times 4x cubed. So I'm using the chain rule again. To the power of 3 times whatever is inside the bracket, or whatever the derivative is. So 12x minus 1. So this f prime, this is g. This is g prime, and I'm going to write f the way it is. So f is x squared minus 2 squared. And all of that, so this is g prime, this is f. So f prime g minus g prime f. And all of that is underneath 4x cubed minus x to the power of 4. And to the power all of that. This is g, but we're going to square it. G squared. Okay? So always have the rules handy. This is very important. So I think, we're doing a couple more. So let's do 2 more. Now, this is ugly. We're going to beautify it first before we derive it. Okay? Alright, so y is equal to 4x squared minus 2. All of that was square rooted. But if you want to beautify the function, you give it an exponent of 1/2. These are equivalent. Okay, so this is like saying the square root of whatever is on the inside. Now let's derive. And we're going to obviously use the chain rule. So dy dx is equal to 1/2. Whatever's in the bracket. 4x squared minus 2 to the power of 1/2 minus 1, which is minus 1/2, times the derivative of what's in the bracket. So times 4 times 2 is 8, 8x. All right. Notice again here that this whole thing is one term, and we can bring things from the denominator to the numerator very easily. What do we have in a numerator? We have something here that has a negative exponent, so we're going to bring it down. And we have something that multiplies the 1, which is 8x. So we're going to leave the 8x here, and we have a 2 on the denominator, and we're going to bring this whole thing down. So this becomes 4x squared minus 2 to the power of what? That's right, 1/2. Should we ever leave an answer with a fraction or a rational exponent? No. No siree. 8x divided by 2. Earlier I said that having something to the power of 1/2 is saying the same thing as the square root of that thing. So the square root of 4x squared minus 2. And this is how we derive this function. Oh, we have 2? Okay. Maybe we'll just do the one more. The video is getting really long now. Now here we have a function within a function within a function. So we're going to have to apply the chain rule a couple of times. dy dx is equal to. Now at the beginning, this whole thing is our u. Let's derive relative to that. For this whole thing, so 4x plus 2 squared to the power of 3, right? So we're going to derive relative to that. Now let's derive what's on the inside. So let's ignore the to the power 4. Let's derive what's in here. Now in the second case, this becomes our u. This is our u, okay? Times 2 times 2, 4u to the power of 1, okay? And then we're going to multiply that by the derivative of what's inside, which is just 4, okay? And here, write this down and try to solve it on your own. And if you have a hard time solving it, then you can write that for me in the comments section. But remember here that before you work with this product, you have to beautify it. You have to beautify the function. This is ugly. Let's change that, okay, first. I hope that this video helped, and I hope that you enjoy deriving functions with me now. And if you have any questions, write it down in the comments section. Have a good day. Bye.